So we have a running Hadoop cluster already there, and we are just trying to see the place where you can find the streaming API. You can see here uh, it's available in contrib folder, and if you go inside that, you would like to explore and take a look into what's available. You will have the Hadoop streaming jar that is available. So we'll use or leverage this jar to initially try to execute our existing processes as a map reduce stuff. So for that one, let's first log in into, we'll just go again back. Let's take a look at our distributed file system and see what's the current structure it has. We'll look into the input part. So we have actually a streaming thing. Let's take a look what is there. They should have the input. You have a data and an output one. If you look into the data, you'll see that there is a single copy of txt version of the Bible copy which we have been using for our sample implementation earlier. So it's the same copy that we have here. We are trying to use with a much lower volume. So this is already available now, and we are pointing to, if you take a look at the output part, I think they should be, yeah, so these are the 5 different runs we have from previous implementations. We'll create a new output folder when we specify. So let's go ahead and try to execute a Hadoop job. With streaming, you know that you don't have to actually write anything. You just have to provide your input and output, and Hadoop streaming has the capability to run your processes in that particular mode. So it's again a jar, then you put your contrib streaming, Hadoop streaming. You'll just now provide, using the input folder, the location of your input data in HDFS. So that is streaming and data. That's the input folder. Using the output attribute, we'll specify the place where we are expecting the output to be there. So we'll just put it here, streaming output, and we'll just put specific folder 6, as well as we'll now specify the mapper, and in our case we'll just use bin/cat, and reducer will be the simplest one. This we'll just put bin/word count. So let's kick it off and we'll see if it succeeds correctly. Simple thing, we are just putting executing or requesting cat to be executed in a map reduce mode, multiple cats taking those individual data files, as well as the word count thing also. Do an enter, it did starts. Okay, now this is interesting. Hadoop as a system as a whole is not running. This is available only when the processes are not able to grab. Okay, I think since we started Hadoop as a Oracle user and node is running under a different user, it's causing the communication gap to happen. So let's stop the processes and then start the cluster as a root user, and then we'll try to execute the same again. So let's browse the file system after it has executed the job with the new details. Output, the others are just temporary directory 9. This is a file, doesn't see anything. It shows the data. Next chunk, I think it's all blank itself. It has not written anything because all what we did was an identity t-shirt, although it shows a size of 4.25. Not sure what's the content of this file, not something which is coming in. So we'll write a more appropriate reducer wherein we know the final data which comes in as an actual script itself. This was more at a capability level, just to execute a certain thing. A word count or other type of script would have helped, because that gives a logical thing. Identity reducer and all, they will anyway not give any specific output and all. Job is simply to transfer whatever that is coming in. In this case, it's not giving that as well. So you can just look that part. Try to, let's see it here. You can access it through the distributed file system and take a look. What could be there? ls slash streaming slash. Yeah, here it shows the online or the name node one part was not showing. You can take a look at that what it shows here is that it has sorted. We know that by default when it passed through the mapper it will have sorted at the output level. So cat was simply reading the file. All what it has sorted is based on the the first line of this is actually sorted all the outputs. The way it has read individual lines, it has sorted the individual lines that it has found in that book, because we know that by default if you don't put anything, the entire line is taken as a key and with a null value. That's what it has done, and that entire key is coming sorted out of the map process. Our identity reducer is simply writing it into the file. So this is a simple example of your uh, streaming API, wherein you just have run a sample combination of your cat typical cat API that we have here, that we have done. We specifically mentioned one reduce task. I think you can change that, but mapper is the cat process, and for reducer, because we did saw that the word count is which could have done the individual word count, very similar to what your uh, word count problem which we practiced earlier used to do. It's not something which is available, so we use the identity reducer, whose job is to simply give the output back. It does not do anything, and it simply assembles it into one and does the job. So this is the most basic upstreaming example that you have, wherein you are using some inbuilt maps, like your processes. In this case, an inbuilt cat program as a mapper, and a inbuilt reducer which comes as part of your Hadoop distribution. So one other important thing that we should take a look at is the details which are available at your job tracker process level. If you go here, it has you can see the streaming job. It specifically tells whether it's a streaming job or whether it's a normal map reduce thing. So it has run actually 4 streaming jobs, and it has completed all that particular part itself. Let's try to, these are all failed jobs, you can see, because they never completed. So this time the failed rate things got specified, but completed one, if you open it, the level of details that you will get at streaming will be much more compared to what you have at the normal process, because streaming is one more level abstraction over your normal Java processes. So it tries to give you some more details here in terms of the map and the reduced time frames that has taken. For the map part, it did started 2 tasks to complete that process, and again that was all internally taken depending upon the capacity and all. try playing around with multiple more files and see how that proportion increases. Reduce, we specifically kept it to 1, and these are the same details. So from a job perspective, it is treated exactly like the normal map reduce which we used to write in Java, but we did saw that this time our executables were normal or predefined processes and all, but not actual Java programs. So this is where it did, and the type of sorting that we observe in the data was also as per the expectation. So individual lines were sorted rather than individual words, because streaming by default takes, if you don't specify any tab as a delimiter, it will take the whole line as a key and corresponding value will be null. And once it comes out of map reduce, we know that the output of map is always sorted. So that's what happened here. The output was sorted and we got the list which was of the same size. So that also you can check that the file system that we saw is having pretty much the same size as that of the initial file. If you take a look here, if you go back, you can see that the size is 4.25, and if you go back and take a look at your data, that is also 4.25, because there is no reduction that is happening. The entire file is getting through the cat process. Your multiple cat processes are running, reading your file, writing it into an intermediate key value pair, wherein the key is the whole line and value is a null value. And then since map output automatically gets sorted before it gets to the reducer, all those lines are getting sorted, and then your identity reducer is simply doing the simple job of writing it to a specific file, and that's what it did here. So in that sense, it was a simple task. That's why you see the input and the output files to be of same size, and then that it is available. So this was a basic example of your streaming using existing processes. Thank you for this exercise session.